Welcome guys to PreCalc Chapter 5, Lesson 1. We're going to be looking at trig identities. Okay, we've got our unit circle here. We're going to be referencing this a few times today. Okay, we're going to be taking a look at reciprocal identities and quotient identities first. And just a heads up guys, the identities that you'll see today, you'll probably be thinking these look crazy. How did we come up with these? But they are very useful, especially if we can commit some of these to memory. They're going to be very useful in future math classes as well as later on in this course, okay? So the first ones we kind of know already. Okay, we've got our reciprocal identities. We know that our cosecant is the reciprocal of sine, which also means that if I were to set this as an equation and solve for sine, my sine of theta is equal to 1 over cosecant theta, right? Okay, they're reciprocals of each other. Same with cosine. Okay, secant is the reciprocal of cosine, so if I were to solve for cosine, cosine is the reciprocal of secant theta. Okay, and same thing with cotangent. If I were to solve for cotangent, that's going to be, if I were to solve for tangent, that is 1 over cotangent of theta. Okay. And then our quotient IDs, you guys know that our tangent of theta is going to be sine over cosine. As far as our unit circle goes, that's going to be y over x. Okay, y over x. And then cotangent is going to be x over y, which is cosine theta over sine of theta. Okay, so let's go ahead and look at a couple examples here. If I have secant of x is equal to 5 over 3, and I'm asked to find cosine of x. Okay, asked to find cosine of x. So I know that my secant of x is equal to 1 over the cosine of x, right? So if I just go ahead and solve that for cosine, cosine of x is equal to 1 over secant of x. Okay, I know that my secant of x is 5 over 3. So I got 1 over 5 over 3. And in case you need any refreshing on our complex fractions, in order to get rid of this fraction in my denominator, I would just multiply by the reciprocal on the bottom. I'll use a different color. Multiply by the reciprocal on the bottom. And if I do it on the bottom, I've got to do it on the top as well. So I'm multiplying by 3 over 5 on the top and the bottom. And let's see, my 3's on the bottom will cancel out, and my 5's leaving me with just a 1 in my denominator, which is perfect. So I've just got 1 times 3 over 5, or 3 over 5. Okay, 3 over 5 would be my answer there. Okay, taking a look at another example. If I'm given cosecant theta is equal to 25 over 7 and secant theta is equal to 25 over 4, and we're asked to find tangent of theta. Okay, asked to find tangent of theta. So first I'm going to use my cosecant here, and I know that my cosecant theta is equal to 1 over sine of theta. So my sine theta is going to be equal to 1 over my cosecant here. So 1 over my 25 over 7, or 7 over 25. Okay, now I need to do the same thing with my secant. Okay, my secant theta is the reciprocal of my cosine. Okay, so my cosine is going to just be the reciprocal of my secant here, which is going to be 24 over 25. Okay, now my tangent I know is sine over cosine. Tangent theta, sine over cosine. So my sine is 7 over 25, and my cosine is 24 over 25. So if I go ahead and I simplify this complex fraction, that's going to be 27 over 25 times 25 over 24. And I can see that my 25s will cancel out, and I'm left with 7 over 24. Okay, for my final answer. Alrighty, so that is using our reciprocal functions there. Now we're going to take a look at our Pythagorean identities, okay? Pythagorean identities, these are where it kind of gets a little bit crazy, okay? But just hang in there. Okay, so we're taking a look at our, say, our unit circle here, okay, just any given circle. But on our unit circle, our radius is just 1, right? Which means that my y is equal to the sine of theta, and my x is equal to cosine theta. Okay, and we've got this is a dot here, a little point on my unit circle. We're just creating a little triangle here with a height of y and a base of x, right? And we've got our Pythagorean theorem laid out here. I've got a squared plus b squared is equal to c squared, or x squared plus y squared is equal to r squared. Okay, in terms of this triangle, right? So what is my x here? Well, my x here is cosine squared theta, right? Or my x is cosine theta, so x squared is going to be cosine squared theta. And my y is sine theta, so y squared is going to be sine squared theta, okay? And here I've got a radius of 1, okay? So 1 squared is just 1. So our first Pythagorean identity is cosine squared theta plus sine squared theta is equal to 1. And this one is probably the most useful. So make sure we box this, make sure we remember this one, okay? But let's take a look at a couple other ones. Just 2 more. I'm only going to prove 1 more, and then I'll give you guys the third one for free, okay? So if I have my x squared plus y squared is equal to r squared like we had earlier, okay, and I were to divide each term by x squared, okay, what would happen here? Okay, well, I got x squared over x squared, that's just 1, okay, plus y squared over x squared equals r squared over x squared, okay? And since we know that tangent of theta is equal to x over y, okay, and we know that tangent theta is equal to y over x, and secant theta is equal to r over x. There we go. Okay, I've got y over x times y over x here, and I've got r over x times r over x here. So I can substitute in and say that this is actually 1 plus tangent squared theta, and that's equal to secant squared theta, okay? Okay, so that is going to be our second Pythagorean ID for our trig functions, okay? And then our last one, I'm not going to prove it, but it has a very similar proof, okay? And it just says that if I have cotangent squared theta plus 1, that's going to be equal to cosecant squared theta, okay? So those are our 3 Pythagorean identities for our trig functions, okay? Make sure we can commit those to memory, and that's going to save us a ton of time in the future. Okay, so let's take a look at a couple examples of using these, okay? If I find, or if I'm asked to find cosecant theta and tangent of theta, and I'm given that cotangent of theta is equal to -3, and our cosine theta is less than 0, okay? Okay, so using this information here, I can tell what quadrant I'm in, right? I can tell what quadrant I'm in. Because I have a cosine, okay, that's less than 0, I know that I'm in either quadrant 2 or 3, okay? In quadrant 2 or 3. However, my cotangent is negative. Okay, so if I have a negative cotangent, that means I must be in Q2. Must be in Q2 because tangent and cotangent are going to be positive in quadrants 1 and 3. Okay, but I have a negative cotangent here, so I've got to be in quadrant 2. Okay, and we'll see why that's important here in a bit. Okay, so we're given cotangent of theta is equal to negative 3. Okay, well, that's also equal to negative 3 over 1, right? So I know that my tangent theta has got to be equal to negative 1 over 3 because that's just the reciprocal. Okay, so we found the first part there pretty easily. Okay, so now we're going to use our Pythagorean identities, and I'm going to say cotangent squared theta plus 1 is equal to cosecant squared theta. Okay, I see cotangent squared theta. Well, that's just going to be this negative 3 squared plus 1 is going to equal my cosecant squared theta. Okay, negative 3 squared is 9 plus 1, that equals 10. So 10 equals my cosecant squared theta. Okay, so now I'm going to have to take the square root of both sides. And when I do that, normally I add this plus or minus here, right? Take the square root of both sides, got to have my plus or minus. However, I know that we're in quadrant 2, right? I know that we're in quadrant 2. Cosecant theta is going to equal. Okay, so that's going to tell me what the sign of this square root is, right? Because my cosecant, okay, is the reciprocal of my sine. And in quadrant 2, we have a positive sign, right? We have positive y values. We have a positive sign. So I'm going to take the plus of this plus or minus and just say that is equal to positive square root of 10. Okay, so that would be my solution there. All right, second example, we're going to find cotangent and secant of x given sine of x is equal to 1 over 6 and cosine of x is greater than 0. Okay, again, I'm going to use this information to figure out what quadrant I am in. Okay, if my sign is positive, I've got to be in 1 or 2, in quadrants 1 or 2. Okay. However, in quadrant 2, my cosine is less than 0, so that tells me that we are in quadrant 1. Okay, so let's go ahead and use, let's see, we're going to use straight away, we're going to use our sine squared theta plus cosine squared theta is equal to 1, okay? And I know that sine squared theta, or sine, is 1 over 6, okay? Cosine squared theta equals 1, so my cosine squared theta is equal to 1 minus 1 over 36. So just distribute this, 1 over 6 squared is 1 over 36. Okay, so that's going to be equal to 35 over 36. Okay, now I can go ahead and I can take the square root of both my sides, okay, because I'm looking for the cosine. Square root of both my sides. Again, I'm given the cosine is greater than 0, okay, so I know I only have to take the positive radical here. And I get cosine of theta is equal to the square root of 35 over 6. All right. So now if I were to take that and I were to say, okay, let's find the secant, because that's what we're looking for. Oh, and I should be using x, sorry, but we'll keep going with theta. Secant of theta, that's just going to be the reciprocal. That's going to be 6 over root 35. And we're going to rationalize that and say 6 root 35 over 35, okay? And that is going to be my secant of theta. Alrighty, now we're going to go and try to find our cotangent, okay? Trying to find cotangent of theta. Well, that's just equal to my cosine divided by sine. Okay, I already know both of those because my cosine I found to be square root of 35. Square root of 35 over 6. And my sine I found to be, or I was given as 1 over 6. So my cotangent is going to be root 35 over 6 times 6 over 1. And that's, my 6's cancel out. and I'm left with just the square root of 35 for my cotangent of theta. Okay. Okay, so now you guys go ahead and work on these 3 practice problems, okay? Finding secant, finding sine, and finding sine and cosine. And pause the video and work on these. Okay, if you got, let me see. If you found secant to be 4/3, and you found sine to be 3/5, and you found sine for c to be negative √5/5, and you found cosine of theta to be equal to negative 2√5/5, then you can go ahead and skip forward on the video because you got all these correct. If you didn't, that's all right. Let's just go ahead and take a look at our solutions right now. Okay, so for A, we're given cosine, asked to find secant. Okay, I know that secant of theta is just the reciprocal of cosine. Okay, so all I need to do is take my cosine and flip it. I'm going to take the denominator, put it in the numerator to the denominator. Okay, so that's just going to be 4/3. Okay, real simple on that one. Okay, for B, I'm given secant and tangent. I'm asked to find the sine. Okay, well, I know that secant theta is equal to 1/cosine theta. Okay, 1/cosine theta. And I know that my cosine is, I'm going to use that information and just flip it and say that my cosine is equal to 4/5. Okay, and then I'm going to say, okay, well, my tangent is just sine over cosine. Okay, and I know that my tangent is equal to 3/4. It's going to be equal to sine theta, or sine of x, over, I'll keep going with theta, over my cosine of 4/5. Okay, so my sine theta is going to be equal to 3/4 times this 4/5. Okay, I'm just taking this equation and solving for sine of theta. And I'll find that my 4's cancel out. And I'm left with just 3/5. Okay. All right, and then lastly, looking at part C, practice problem C. Okay, I'm given cotangent, and I'm given that cosine is less than 0. Okay, that tells me that I'm working in quadrant 3. Okay, quadrant 3. We've got to be able to understand, given our clues, what quadrant we're working on, because that's going to help us with our signs and help us get the correct answer on questions like these. Okay, so let's go ahead and start off by saying we're going to use one of our identities. We're going to say cotangent squared theta is plus 1 is equal to cosecant squared theta. Since I'm given cotangent, that's just 2. So I'll have 2 squared plus 1 is equal to cosecant squared theta. So I'll have 5. 5 is equal to cosecant squared theta. Okay, take the square root of both sides. And I'm left with cosecant of theta is equal to negative square root of 5. Okay, because I'm in quadrant 3, I know that my cosecant is going to be negative square root of 5. Okay, And I can use that information to say, okay, if cosecant of theta is equal to negative square root of 5, then sine of theta is equal to negative 1 over the square root of 5, which when I rationalize that is going to be root 5, negative root 5 over 5, okay? So that's going to be my sine. As my sine. And we're asked to find cosine as well. So let's do that. Okay, my cosine, I'm just going to use the fact that my cotangent is equal to cosine of theta over sine of theta. Okay, because I already know my cotangent is 2, and I already know that my sine of theta is negative root 5 over 5. So all I have to do to solve for cosine theta is multiply both sides by negative root 5 over 5. And I find that cosine theta is equal to negative 2 root 5 over 5, okay? Okay, so one of the main things we need to be able to do in these situations is understand which quadrant we're in so we know what sign we are dealing with, okay, for our sine and our cosine and any of our other trig functions, okay? All right, now let's take a look at some cofunction IDs, okay? So for this one, we're going to head back up to the unit circle, okay? But what this is saying is that if I have sine of an angle, and all the way back up here. Okay, let's take a look at pi over 3 here, okay, or 60 degrees. Okay, cosine of pi over 3 we can see is 1/2, okay? Now if you notice on your unit circle, there's really only 3 combinations here, 3 coordinates. I've got root 3 over 2, I've got 1 over 2, and I've got root 2 over 2. And everything else, and then I've got the negatives of those. But everything else is just a combination of those 3 coordinates, right? Okay, so if I'm given the cosine of pi over 3, okay, where can I find an angle where I have a sine that's equal to that cosine? Okay, so here my cosine is 1/2. Where can I find an angle that has a sine of that same 1/2? Okay, so when I look at this, I've got pi over 3. The cosine of that is 1/2. Okay, and what my cofunction IDs tell me is that if I go to pi over 2 and I just subtract my original angle, I'm going to find that I have, if I started off with cosine, I'll have sine. If I started off with sine, I'll have cosine. Same with tangent and cotangent. Same with secant and cosecant. Okay, these are our cofunction IDs. So here I've got cosine of theta is equal to, or cosine of my pi over 3 is equal to 1/2. So if I go to pi over 2 and I subtract theta, so I'm going to subtract this 60 degrees, okay? Keep in mind I'm subtracting, so I'm going clockwise on my curve here, okay? So I'm going to pi over 2 and I'm subtracting 60 degrees. That's going to land me here at 30 degrees or pi over 6. And look here, I have a sine at pi over 6 of 1/2. Okay, so it checks out. Okay, so you can do that with any of your relationships here, any of your sines and cosines, tangents and cotangents, and secants and cosecants as well. Okay, you're just going to go up to pi over 2, and you're going to subtract whatever the original angle is from that, okay, and you'll have your cofunction ID. Okay, so let's take a look at how we can use that. Okay, so here's what all of our cofunction IDs look like. So sine of theta is equal to cosine of pi over 2 minus theta. Okay, cosine theta is equal to sine of pi over 2 minus theta. Okay, so these two go together. Okay, my secant goes to my cosecant because it's the cofunction ID. So secant theta is equal to the cosecant of pi over 2 minus theta. And cosecant theta is equal to secant of pi over 2 minus theta, okay? And same with tangent and cotangent. We'll go over those. All right, so again, we're looking at odd versus even, okay? Now, we've been through this earlier, and we said in a previous chapter that even is when I plug in, if I have f of negative x, okay, that is equal to f of x. All right, and we took a look at that graphically, and we said, okay, that's when we are symmetric about the y-axis, right? Symmetric about the y-axis. And if I have an odd function, okay, if I have f of a negative x, that turns the entire function negative. So that's going to be negative f of x. And we saw that that means we have symmetry, we have point symmetry about the origin, okay? Now, we kind of spoke about this when we were looking at the graphs of sines, cosines, tangents, and the reciprocals, okay? But we can see again that my sines and my tangent functions are going to have this odd characteristic, while cosine and secant are going to have an even characteristic, okay? So let's go ahead and use this along with our co-function IDs to solve some examples. Okay, over here, I've got sine of x is equal to negative 0.37, and I'm asked to find the cosine of x minus pi over 2. Okay, we're going to find cosine of x minus pi over 2. So what I want to do first here is I'm going to say, okay, cosine, I'm going to factor out, because this looks sort of like what I want to have with my co-function ID, but my signs are opposite. And when my signs are opposite, I can go ahead and factor out a negative, right? We've done that before with our factors. So if I factor out a negative, then I'm going to have positive pi over 2 minus x, okay, for my cosine. Okay. So using my using my odd or even, okay, I've got cosine of negative, we'll call this theta in here, okay, which is going to be equal to just cosine of theta. So I can really just get rid of that negative there because of this even characteristic that we have, okay? So because that's even, we're allowed to kind of get rid of that negative sign, okay? So I know that if I have the sine of x and cosine of pi over 2 minus x, okay, since these are my co-functions, right, sine goes with cosine, then my cosine here is going to be equal to what my sine is equal to here. So I've got negative 0.37 for my answer. Okay. Okay, so using both our odd and even characteristics along with our co-function IDs to solve that one. So you guys go ahead, pause the video, and try the same thing here for this one. I'm given cosine of x is equal to negative 0.75, and that's to find the sine of x minus pi over 2. Okay, so if you got positive 0.75, then you can go ahead and skip ahead because you got it correct. If not, no worries. Let's go ahead and solve this one together then. Okay, so I'm going to do the same thing I did earlier, and I'm going to factor out a negative from my sine here. So it's going to be negative pi over 2 minus x. Okay, and since my sine is odd, then I'm going to bring that negative out to the front. So it's going to be negative sine of pi over 2 minus x. Okay. Using my co-function IDs, okay, cosine is equal to sine of pi over 2 minus x. Okay. So since my cosine is this negative 0.75, okay, and I have opposite of that because I pulled this negative out here because of our odd characteristic, then that's going to give us a positive, because I have a negative times a negative, that's a positive 0.75. So that is what my answer would be for that one. Alrighty, now we're going to take a look at simplifying trig functions, okay? Simplifying trig expressions. Okay, there's not always one specific way to do these. Okay, so we're going to just take a look at a few different types of expressions that we might be given and how we might be able to simplify them, okay? Okay, so this first one here, I'm asked to simplify secant of x minus tangent of x times sine of x. Okay, well, let's go ahead and rewrite this in terms of sines and cosines, only sines and cosines. Okay, so my secant of x here I know is 1 over cosine x. Okay, minus tangent of x is just sine of x. So I've got sine of x times sine of x over cosine of x, okay? Because my tangent of x is sine x over cosine x. Okay, so here I have 1 minus sine squared of x over cosine of x, okay? Well, earlier we said that cosine squared x plus sine squared x is equal to 1, right? Okay, so if I solve this for cosine squared x, that equals 1 minus sine squared x. Well, that's exactly what we have here. Okay, so I can actually substitute in this cosine squared x for my 1 minus sine squared x. Okay, so that's going to be over cosine of x. And when I simplify that, I'm just going to have cosine of x for my final answer. Okay. Okay, taking a look at our second example, we're asked to simplify negative cosecant of pi over 2 minus x minus tangent squared x times secant squared x, okay? Okay, so let's go ahead and I'm going to rewrite this as using my cofunction IDs. Okay, so I can rewrite cosecant as, this is actually going to be just negative secant of x, okay? If I go and look at my cofunction IDs, I know that those two are equal to each other, okay? Okay, minus, let's see, tangent squared x times secant of x, okay? Well, I can go ahead now and I can factor out my secant my secant of x. So if I factor out secant x, I'm left with negative 1 minus tangent squared x in my parentheses, okay? And using my Pythagorean IDs, okay, I know that I've got here, this is the same thing as what? Secant squared x, okay? If you go back and look at your Pythagorean identities, then you'll see that those two are equal to each other. Well, first I need to modify this real quick. I'm going to factor out a negative 1. So this is going to be negative secant x. And this is going to be 1 plus tangent squared x. And this is actually what is going to be equal to secant squared x. Okay. So when I simplify here, I have negative secant x times secant squared x, which is going to give me a final simplified answer of negative secant cubed x. Okay. So you guys go ahead and work on these two practice problems. Simplifying cosine x over 1 plus sine of x plus 1 plus sine of x over cosine x, and then rewriting this fraction here to eliminate the fraction, okay? I want you to simplify this in a way that eliminates the fraction completely. So you guys pause the video and work on these ones on your own. Okay, if you got For answer A, answer for A, if you got 2 secant x, and then for B, if you got 1 plus sine of x, then you are done. Congratulations, you have finished the video. If you didn't, then stick around for these 2 minutes and we will figure out these problems together, okay? So for our A, what are we gonna do first? Well, first thing we need to do is find our least common denominator. Okay, our least common denominator is gonna be 1 plus sine of x times cosine x, okay? So I'm gonna multiply everything through by my least common denominator, and when I do that, I'll have cosine x cosine squared x over 1 plus sine of x times cosine x plus 1 plus sine squared x, 1 plus sine of x, quantity squared, all over 1 plus sine of x, all over cosine x. So all I did was I said, okay, my least common denominator is this. What is this first term missing from that? Well, all it's missing is a cosine of x, so I just multiplied the numerator and denominator by what it was missing. It was missing that cosine of x. So now I have cosine times cosine, that's cosine squared, and then I have my cosine x in the denominator as well. Same thing for my second term. If I have, what am I missing for my least common denominator? Well, I was missing this 1 plus sine of x, so I multiplied the denominator and the numerator by this 1 plus sine of x, okay? So I can go ahead and simplify this as, this is going to simplify to 1 plus 2 sine of x plus sine squared x. Okay, if I were to expand that and FOIL it, that's what I would get. Okay, so now when I bring these two together, I get cosine squared x plus sine squared x plus 1 plus 2 sine of x. Okay, I'm just combining my numerators here, combining what I have here in blue with my cosine squared x, and that's all going to be over 1 plus sine of x times cosine of x. Okay, now what do I realize here? I should realize that I have a cosine squared x plus sine squared x. That is going to simplify to just 1. Okay, so now I can have a look and say, I'm going to have 1 plus 1, so I'm going to have 2 plus 2 sine of x over 1 plus sine of x times cosine x. Okay, now I can go ahead and factor 2 out of my numerator, so I'll have 2 times 1 plus sine of x over 1 plus sine of x times my cosine x. And here I can see that my 1 plus sine of x will cancel out, and I'm left with just 2 over cosine x, or 2 secant x. 2 secant x for my final answer. Okay, so now let's take a look at rewriting to eliminate our fraction of our cosine squared x over 1 minus sine of x. Okay, when we want to eliminate the fraction like this, first thing we're going to do, we're going to rely on our knowledge of conjugates, okay? So if I have cosine squared x times 1 minus sine squared x, or sine of x, okay, what's the conjugate of my denominator? Conjugate is going to be 1 plus sine of x. Okay, and if I multiply the bottom, we know that I have to multiply the top. Okay, so I'm multiplying by this term here, okay, based off of my conjugate of my denominator. And when I do that, I'm going to have this cosine squared x times 1 plus sine x over, okay, this is going to FOIL into, this is a minus b times a plus b. So that's going to FOIL into a squared minus b squared. Well, my a is 1, so 1 squared is just 1. Okay, minus sine squared x. Okay, minus my b squared, which is just sine squared x. So if I go ahead and write that out, I've got a minus b times a plus b, and that's going to FOIL into a squared minus b squared every time. Okay. Okay, so what do I have here? I've got let's see, cosine squared x plus sine squared x. That equals 1, right? So again, if I solve for cosine squared x, that's going to be equal to 1 minus sine squared x, which is what I have here. All right? Okay, so I'm going to replace this 1 minus sine squared x with the cosine squared x. So I'll have cosine squared x times 1 plus sine squared x, or sine of x, all over cosine squared x. And we'll see that my cosine squared x's will cancel out, and I'm left with just 1 plus the sine of x. Okay, so that is how I might simplify in order to eliminate a denominator. Okay, if any of that was confusing, feel free to re-watch the video. And if it's still confusing, then you can come ask me for questions later.